Okay, everyone, welcome to this nice and freezing room and to Pablo's seminar. And welcome to all our Zoomers as well, anyone listening to the recording. And I won't take more of Pablo's time. I'll just tell you that he is his undergraduate studies in Colombia and his PhD studies here, as many of you know, at UQ. And now he's an honorary research fellow with CBCS and UQ and starting his position in Switzerland, which he'll tell you about a bit more. And he is a very talented researcher. So
Thank you.
if you're looking for someone to collaborate with in Switzerland, here's your man. Thank you, Pablo.
Salid. Well, okay. Well, thanks for coming. Today I'm going to talk about how to maximize key habitat retention on the limited budgets. And I'm going to use Colombia, that is a mega diverse country, as a case study. And particularly forest-dependent species, forest-dependent bird species, and how to maximize the retention of the habitat in the landscape. So before we get into that, I wanted to thank a lot of people that I have worked along my time here, and I hope to continue working with. These are not all, but there's a lot of people, and I'm really happy and honored to have been part and still be part of CBCS. They inspire me to do most of the work that I have done along the years. Okay, so to start with, I will start with the protected areas and how they are like a cornerstone of biodiversity protection. That's one of the main tools that we use to protect biodiversity. The protected areas have been increasing not only in number, but in area a long time, in the marine realm and also in the terrestrial realm. And they have been increasing exponentially, and they are actually gonna continue increase with time. The Aichi target 11 aim to have at least 17% of the area of each country under protection. And now the post-2020 biodiversity framework is aiming to have 30% of the earth protected by 2030. And there's even more ambitious targets of having 50% of half of the earth protected for conservation. So in relation to this, if we want to expand the protected area, what would be the best way to do it? So there's very different ways of defining which priorities would be the most important to protect in order to expand the protected area. So this is different examples of different ways of approaches to which area will be the most important to protect in the near future. So the ones you see on top are different options that have been named, but you can boil those down into two different categories, which can be they are not black and white. There's things in the middle, but for like identification, you can divide them in two. The reactive approach, that is, we should protect the places that are in highest risk of being lost in the near future, because those are the ones that need more attention, and those are the ones that are going to disappear. But also there's the other approach, that is the proactive one. That is, there's these areas that have very low impact from human impact, and have the more pristine or the more natural ecosystems and communities, and they can be also sources of population of species to other places. So maybe we should protect those ones and avoid any intervention or the lowest intervention on those areas. But if we look actually at the distribution of protected areas and globally, we can see that there's a bias on the actual protected area network in the world to date. So if we see, for example, these three examples, the one on the right is for the United States protected area system, and basically this is the proportion, the proportion between the relation between the area that is in a certain category inside protected areas against the area of the whole country in relation to different things. So, for example, values that are under 0 means that there's a high proportion of those types of areas inside in the country in relation to the protected areas, and the opposite means, so values that are above 0 means that there's more of those areas inside the protected areas in comparison to the whole country. So you can see that for many variables. This is not working, but you can see that for elevation, protected areas have higher elevation than the country as a whole, more slope, more distant, farther away from roads, less productive areas. The same happens for Colombia, that is the opposite side. And for Australia, in the middle, we can see the same, that is the amount of area, the percentage of the area in relation to fertility in one axis and slope in the other. So basically, protected areas tend to be in areas that with more steep and less fertile. So what in relation to how this associates with the cost effectiveness of protection? So basically, these areas, because are they more far away from roads and the ones that have less economic potential, they are the cheapest. So in certain ways, protecting them could be a good can be a good outcome, because maybe they are very isolated, they are cheap, so we can have, with a limited budget, we can have a lot of area that is maybe not to intervene or not to with not too much human pressure. And apart from that, it's important to account for the cost of protection, because we have limited budgets in conservation. So this is an example from a study that shows that in blue, there is so in the y-axis is the benefit for conservation. Let's talk about in those terms, and in the x-axis is the cost. So you can see that they have different conservation prioritizations taking into account different things. So the one that takes into account benefit and cost is the most cost effective. That is the one that is blue full line, in relation to only taking into account only the cost or only the benefit. So if we want to achieve the best conservation actions with a limited budget, we have to take into account the cost and the conservation benefit. Also, protected areas are not the holy grail. Like, they are really useful, and they are really they have avoid from the nature from being destroyed, but they are not perfect. So this is an article on the right that shows that 1/3 of protected areas at a global scale have been aren't on the high human pressure, and the other article is the green bars show the deforestation inside protected areas, and the gray bars show the counterfactual of areas similar but without protection. So if you see, in overall, protected areas do have deforestation, but they have had less deforestation than what would have happened if there was no protected areas. But also, if you see for that changes between different regions. So there's some regions where actually protected areas have had more deforestation than what would have happened if there was no protection. So in not all the cases, protected areas are perfect. So we have to be careful where to put them and how to put them and how to manage them. The same for Australia. So I'm not going to go in detail here, but this is another article that actually shows the same, that we avoid deforestation with protected areas, but they are not perfect. There's deforestation in protected areas. And then, so after all this, with our co-authors, we wanted we thought about, so what is the purpose of protecting? What do we want to achieve with expanding the protection areas networking globally or in a place? So most like the majority of the research has been focused on representation as having as much species and lands and ecosystems inside protected areas as we can, because those are the places where they can be most safe from human pressure. And this is an example. This is a paper from our friend that is also from CBCS, that he showed that the representation, the bars are different conservation futures, and on the last 10 years, they have increased the representation of different taxons. However, do we only want to focus on representation, or do we want to focus also on maximizing the retention of conservation futures in the landscape? So protected areas can be good to safeguard key biodiversity futures, but also we have to take into account that there's conservation futures outside protected areas, and that we need to also that they are losing the forest. So a better way to approach this is how we can expand the protected area system in the world or in a country in order to avoid the maximum, to maximize the retention of the conservation features in the landscape, not only inside protected areas. So that was, so this is a good example of how this can be seen in space. So here the green line shows how much species, the y-axis is showing the number of species that we're losing a long time. The dashed line is basically the present, and so the green lines tells you the amount of species that we have at the moment with the protected areas that we have established and all the conservation actions that we have done. Blue line shows what would have happened if we didn't have protected areas. So we will have lost a certain more species that we have already lost. And what would have, and the red line shows how many species we had lost if we didn't have any other non-spatial conservation action. So now that's the present, and into the future, we can maximize, we can improve the retention of species into the future if we expand the protected area in a way that maximizes the retention of those species, not only inside, but in the landscape. So that dashed line can be higher depending on when we establish the protected areas in order to maximize the retention. And this is another paper that also from CBCS members that also talks about that in a broader sense. We can think on the retention of expanding the conservation actions, not only for the representation, but the retention of different conservation features, not only for species, but also for the interactions between humans and nature, that in most cases have to be done inside protected areas, in some cases, but outside, and also carbon storage, so there's different targets. So instead of thinking how many species we have inside a protected area, how much, in this case, forest, we need to retain in the world in order to maintain all these conservation objectives that we want. So based on that, the aim of our study was to try to understand the impact and cost effectiveness of alternative protected area expansion scenarios on the retention of species habitat across an entire region. And we used Colombia as a case study, and particularly Colombian forest dependent bird species as our outcome variable. Why Colombia? This can be done for any country, but we use Colombia because I'm Colombian, but also because it has around 10% of the global biodiversity in its borders, and it has around 54% of the country covered by forest. That is one of the most biodiverse ecosystems in the world. And apart from that, it has a lot of issues and problems in relation to deforestation and loss of habitat. And we need to improve the conservation planning, especially after there was a big conflict in Colombia, and after the conflict, the deforestation accelerated. So we need to do our good conservation planning in order to avoid the loss. So in order to do that, we already had a model of deforestation for Colombia that we published in the past. Using different variables and deforestation patterns, we were able to generate a deforestation model for the country that's spatially explicit. So we knew which places of the country we estimated which places in the country had the highest risk of being deforested and which the lowest. In this case, the red areas are the places that have the highest risk of being deforested. And with that model, what we used, we created 3 approaches to protect area expansion to maximize the representation of bird species. So we used one that was a risk prevention approach. So targeting the areas that were at high risk of deforestation in order to avoid their loss. A risk avoidance one that basically targeted the areas that were more intact and had less deforestation, but also were with the more intact ecosystems. And a risk neutral that basically didn't take into account deforestation at all. So we use the deforestation model for that. And this is a bit of a conceptual framework of what we did. So we use these 3 approaches that I mentioned already, and we used Markson to generate the representation targets of thresholds of how many, if we expanded the protected area to have at least 20% of each forest dependent species inside the protected areas, 30, 40, 50, and 60 with those approaches that I just mentioned. So basically we had at the end 15 expansion scenarios based on those combinations of the approaches and the targets. And with that information, we were able to assess first how much representation we had under these different scenarios. So how much in average habitat of each species we had under those scenarios. But also we had generated some projections into the future of forest cover. So we had forest projections until 2015 under these different 15 scenarios. So if we expanded the protected areas in these different scenarios, how much forest we will have retained in Colombia by 2050. So with that, we had also assessed the forest retained by 2015 under each scenario. It's a little bit complicated. And then we also did that for each bird species. So we also were able to assess the retained forest for each species by 2050. So we had an average retention of forest habitat for each species and for all the species and forest as a whole, and the total area needed for each approach and the cost of acquiring that land for each of those approaches. So this is just to visualize, but it's not that important. So in green is the risk avoidance approach for a 30% representation threshold, and in red is the risk prevention approach, and in purple is the areas that are shared in Colombia, and in black is the ones that are very protected. So this is some of the results. This is a lot of information, but we're going to focus. So a lot of measures that we acquire based on the results, but we are going to focus on this column. So this is the amount of area in average needed for kilometer square spent purchase. So how much in average we needed for each square kilometer that we acquire under the different approaches. So you can see that for the risk prevention approach, let's see the first three examples. The most expensive approach is the risk prevention. So if you target areas that are at high risk of deforestation, then they will be the most expensive, and you will have the less area for the same amount of money. But if in comparison with the risk avoidance, that has the cheapest, because those areas are less expensive because are very far away from the economic development. But if you focus on actually the return, the cost effectiveness in relation not only to the representation inside the protected area, but the retention of forest habitat in the landscape, then you get the opposite result. So you get that if your objective is the retention of habitat or forest in the landscape, the cheapest approach is the risk prevention. So that's basically the way you frame your objectives can drastically change what will be the best approach to expand the protected area system. This can also be seen in these graphs, that basically the y-axis shows the forest retained, the average habitat retained for all the 550 forest dependent species, and the average habitat retained for only the endemic ones. So if you want to retain 89% of the forest in the country by 2050, you will need around twice the amount of area, and 3 times the money that with the risk prevention approach in relation to the risk avoidance. The same for the retention of forest habitat. So if you want to retain around 83% of the forest habitat for all the forest dependent species by 2050, you will have to pay. You will need 2 times more area under the risk avoidance than the risk prevention approach. And similarly to with the endemic ones. And also we wanted to see what that meant for particular species. So we wanted to see what happens if we see what happens to individual species. So these are the endemic species of Colombia. And we saw that there's examples, for example, these 2 that are endangered and endemic for the country. Sorry, I have to explain this first. So the black points are the business as usual retention of forest for that species. The yellow one is the risk avoidance, and the red one is the risk inclusion. So how that species retention changes depending on how you expand the protected area on the different scenarios, or if you don't do nothing at all. So in the case of these 2 species, that is one is an oropendol and the other one is a dove, there's no actual difference between the the scenarios. So it doesn't matter where you put protected areas, and it actually doesn't matter. There's no difference between the business as usual scenario and the other expansion. So for those species, there's actually no need for expansion of protected areas. So maybe what we want for those species is to better understand their ecology, better understand the other conservation things that they are, for why they are being endangered. And even more important, we might not want to include them on conservation prioritizations because they are diluting the effect of what we actually want to account for in a conservation prioritization. These species are not actually needing protection. On the other hand, there's other species where there's a big change between the not doing anything and doing increasing the protected area for those species. So for those species, it's critical to expand the protected area to protect them and to understand also the drivers of their loss. So as a conclusion from this study, so we want to preferentially, based on our analysis, we found that for Colombia, we would prefer to increase the protected area systems in areas where there is higher deforestation risk. If the purpose is to increase the retention of species habitat in the future. And it's important to identify for each species what is the actual risk that they have, if it's protection and other things, in order to decide if we want to include them or not in certain types of prioritizations or actions that we're trying to do for ecosystems or landscapes. But then also we wanted to, we thought about the idea of, so what this means, having this reactive approach or focusing on this reactive approach for the country. So we know that these areas are the ones that are where there's more conflict with people because they are the places where there's more actual economic potential. So that's where people want to be. And so what should we do? So in this regard, what we thought is maybe we don't need, so in these places, it's maybe really hard to have strict protection. In some cases, well, you hope to have or you need, but you will have to look for other options like less strict protected areas or other type of area-based conservation alternatives. So for example, we know that indigenous protected areas overlap with a lot of protected areas and also natural ecosystems. And also we know this article is very, very nice that it's a recent one that shows that the green line represents the baseline. Everything underneath that line shows avoided deforestation. And we see that indigenous land are effective preventing deforestation in relation to protected areas, and also if they are combined, they also avoid deforestation. So these are all alternatives. There are things like conservation concessions and other things that we can use. So that's for now, and this is a really small teaser of another paper that we're working on. So I'm going to be very fast on this, but basically we know that mammals become more nocturnal with human pressure. So this is something that it has been, there's already a good amount of evidence showing that mammals become more nocturnal when there's higher human pressure in the ecosystems. And this is a very nice paper that shows that for all the world, mammals become more nocturnal, and this has repercussions for the ecology of the species, for the conservation, and I'm talking more about that in the future. But what about birds? We haven't assessed what happened with birds when there's high human pressure, because it's harder and other things. But so we try to first understand what has been done in relation to that, and we found that there's some studies, emerging evidence that show that actually they do have an impact with higher human pressure as expected, but that impact might be different from mammals. So in this case, there's this study here on the right, shows squares is the species that are in fragmented landscapes, and circles are the species that are in not fragmented landscapes. And this is the different types of categories of what birds can do. So there's like ones that will do latent variable, others that are constant along day, and others that are early and lazy. And you can see that the ones that are in fragmented landscapes tend to become more in the middle of the day and early in the day in relation to the ones that are in conserved landscapes. This is another similar study where they basically assess how the fragmentation, how disturbance affects bird daily activity patterns. And for native forests, they have one pattern, and they change, that pattern changes with in relation to other forests that are disturbed. So based on this, we also knew that other type, like mammals and birds, have different responses in relation to other things that change with human pressure, like, for example, the abundance of the species and the extinction and local extinction of species. But this article is a global review that shows actually that the response from birds is different from that of mammals. So you see that hunting, for example, there's 156 studies that show a negative response from mammals to hunting, but for birds is actually in general positive, and for degradation is also positive in opposite to mammals. While conversion is really strong for birds, while for mammals is negative but not as strong. Also, we know that there are factors that affect the behavior of birds. The interaction between human pressure and birds' daily activity patterns and behavior. So the bigger that an animal is, the higher the possibility of it being hunted, and being hunted or persecuted. So that's a factor that affects mammals, and you can see it in that paper that it's a really nice paper in Science. And here in the same paper, there's hunting is more prevalent in species that are more heavy, both in mammals and in birds. And also the dietary condition of species affects how these human pressures affect. So the different types of ways of feeding affects the hunting, the degradation, and the conservation, and the conversion effects on mammals and birds differently. So we investigated this for mammals and birds in Colombia, and we wanted to know the impacts of human pressure on mammals and birds in the country. Why Colombia? Because I'm Colombian. But also because it has doubled the human pressure in the country in the last 15 years. So what we did is we had a lot of information on camera traps, around 200 camera traps and 1,400 day traps for the study site. This is in the Orinoco region in Colombia. And these are the three different sites. They are in the colors are the human pressure. Blue colors are lower human pressure, and red colors are higher human pressure. And we can see that the sites go from low human pressure to really high. The red points are the cameras. So what we did a methodology that was already used for mammals in the Amazon, in Brazil, and we basically defined day records as the records before sunrise and after sunrise and before sunset, and the night records after sunset and before sunrise. So each record has a time, and we divide them into categories. And we define the exact timing of the day based on the US Naval Observatory that has information on the exact sunrise and sunset times for the different places in the world. And we used a general linear mixed model where the response variable was a binomial variable, basically the probability of the species being nocturnal, where was even nocturnal day or night records, a binomial response, and the predictor variables were the human footprint and the site as a random effect to account for variation between sites. So these are the results. So basically, we found that from the mammals that had enough data to be able to be analyzed, 36% of those mammals had changes, statistically significant changes in the daily activity patterns, with all of them. So in this graph, the diurnality is 1 is completely diurnal and 0 is completely nocturnal, and this is the increase in human pressure. So for most of the species, you can see that with increased human pressure, the species becomes more nocturnal. So this supports the evidence that shows that at a global scale that mammals become more nocturnal. And for birds, we found the opposite pattern. That was kind of interesting. So we found that 45% of the species that had enough information became more diurnal, with only one becoming more nocturnal. There was the parwaque, that is a crepuscular species that is different characteristics, and we kind of thought we knew why that happened differently for that species. This is a more neatly way of seeing it. So basically, this is the shift on daily activity pattern for the different species that has significant change. For mammals, all mammals become more nocturnal, and birds, one become more nocturnal and the others become more diurnal. None of the species for mammals weighed more than 1 kilo, so probably hunting was not a big thing for those species. All of them were omnivorous, so maybe not a specific diet. The diet was not very influential, and the only one was opportunistically hunted. So maybe hunting is not our thing. So maybe there's something else that is affecting those species. And for mammals, there were species that were even 13 kilos. There was a lot of also mixed diets, so maybe that's not the most important part. But 3 of them were hunted, so maybe hunting is a really important thing for the mammals, at least in this particular area. And just as a discussion, so for birds, the increase in diurnality probably is not related to direct human pressures like hunting, but more changes in the landscape. So fragmentation affects the disponibility, the availability of food resources, and that changes in the availability of food resources can affect the species diurnality activity, because probably they have to forage more in the day because there's less food, so they have to move more to get the food if there's less. But while for mammals, it supports or also supports global trends, and hunting probably is a big factor in for these mammals. But definitely there's more research. We need more research on these aspects, especially for invertebrates that are not mammals and how they react to human pressure, not only in reducing the population or being extinct locally, but how their behavior changes. And these shifts have consequences for many things, for fitness, for population persistence, for community, for a lot of things. So it's important to account these changes in behavior in actually conservation actions and prioritization. In this case, prioritization at a day scale. So time changes in the day. When are the species having these interactions with people that are negative? And what can we do in those specific times of the day to avoid that interaction? So basically prioritizing not on time, not on space, but on time. And that's basically all. Thank you.